Nursing 431, Populations and Samples. The course learning outcomes are integrate knowledge from other disciplines when utilizing the research process and critically analyze research findings. The weekly learning outcomes include examine various methods of probability and non-probability sampling, discuss sampling errors and sampling bias, demonstrate an understanding of the concept of measurement, identify the various data collection methods, critique selected qualitative research articles. The population is a complete set of persons or objects that possess some common characteristic that is of interest to the researcher. The population of a study is composed of two groups, the target population and the accessible population. The target population is composed of the entire group of people or subjects to which the researcher wishes to generalize the findings of a study. It consists of people or things that meet the designated set of criteria of interest of the researcher. The accessible population is the group of people or objects that is available to the researcher for a particular study. The conclusions of the research study are based on data obtained from the accessible population, and statistical inferences should be made only to the group from which the sample was randomly selected. The sample is a subset of the population that is selected to represent the population. The method of selection of the sample and the sample size will determine how representative a sample is of the population. Other terms associated with the sample are element and sampling frame. An element is a single member of a population. Sampling frame is a listing of all elements. Samples are chosen through two types of sampling procedures, probability and non-probability. Probability sampling is the use of random sampling process to obtain a sample from members or elements of a population. It includes simple, stratified cluster, and systematic random sampling techniques. Random selection is a key term in probability sampling definition. Random selection means that each study subject or object has an equal chance of being placed into any one of the study samples. Non-probability sampling is a sampling process in which the sample elements are chosen from the population through non-random methods. It includes convenience sampling, quota sampling, and purposeful methods. In non-probability sampling, the sample elements are chosen from the population by non-random methods. These methods are more likely to produce a biased sample, and the researcher cannot estimate the probability that each element of the population will be included in the sample. This restricts the ability to generalize the results that are made through the study. The three most frequently used non-probability sampling techniques are convenience, quota, and purposive. Convenience sampling involves choosing the most readily available people or objects for a study. These elements may or may not be typical of the population. Snowball sampling is a type of convenience sampling method that involves the assistance of study subjects to obtain other potential subjects. It is called network sampling since the study subjects provide other study subjects. It is helpful in finding people who are reluctant to make their identity known. Quota sampling is a non-probability sampling procedure in which the researcher divides the population into homogeneous strata and then obtains sample elements from each of the strata through convenience samples. These variables frequently include subject attributes such as age, gender, and educational background. The number of elements chosen from each stratum is generally in proportion to the size of the stratum in the total population. Purposive sampling is a non-probability sampling procedure in which the researcher uses personal judgment to select subjects who are considered to be representative of the population. Many qualitative studies use this type of sample. Advantages for using non-probability sampling procedures are savings in time and money. A major disadvantage of using non-probability sampling procedures is that the elements are not chosen randomly and thus are not typical of the population. Research studies involve involuntary subjects regardless of the sampling procedure used. Even when a random sampling method is used, the ethics of research requires that subjects must voluntarily agree to participate in the study. Research data are based on voluntary responses. Unless all selected members of the sample actually participate in the research study, the potential for a biased sample is present. Volunteers are subjects who approach the researcher asking to participate in the study. This type of sample is different from a convenience sample in which the researcher approaches the potential subjects and asks them to participate in the study. Random sampling involves the selection of a sample from the population. Random assignment involves the unbiased placement of subjects from a sample into either the experimental or the control groups in a study. A threefold randomization process for experimental studies that would represent the ideal study procedure is determined by subjects randomly selected from the population, when subjects are randomly assigned to groups, and when experimental treatments are randomly assigned to the groups. Research studies are classified as longitudinal or cross-sectional, depending on the time frame for selecting and studying subjects. A longitudinal study follows subjects over a period of time into the future. A cohort study is a special type of longitudinal study in which subjects are studied who have been born during one particular period or who have similar backgrounds. The number of data collection periods and time intervals in between the data collection points depend on the nature and the length of the study. Data are gathered from the same subjects several times to determine changes associated with passage of the time. A cross-sectional study examines subjects at one point in time. Data are gathered on subjects at only one point in time. Cross-sectional studies examine several different groups that are thought to be representative of different age groups, time periods, or developmental states. Longitudinal studies are a more accurate method of studying changes that occur over time. Cross-sectional studies are conducted because they are less expensive and easier to conduct. No simple rule exists to determine the correct sample size. Qualitative studies use much smaller samples than quantitative studies. Some factors to be considered in quantitative studies are the homogeneity of the population. With the homogeneous population, a small sample may suffice. The degree of precision desired by the researcher, for example, a larger sample equals greater precision, and the type of sampling procedure that will be used. Probability sampling requires smaller samples than non-probability sampling. A sample size of 100 ensures the benefits of central limit theorem. Sample sizes as small as 30 are generally adequate to ensure that the sampling distribution of the mean will closely approximate the normal curve. Larger sample sizes may be needed when many uncontrolled variables are present. Small differences are expected in members of the population on the variable of interest. The population must be divided into subgroups. The dropout rate among subjects is expected to be high, and statistical tests are used that require minimum sample sizes. Power analysis is a procedure that can be used to determine the needed sample size for a research study. The power of a statistical test is its ability to detect statistical significance in the study when it is present. When power is low, the likelihood of making a type 2 error is high. Nearly all external funding sources require that a power analysis be conducted to determine the optimum sample size for the proposed study. Most nursing research studies are limited to small, convenient samples. Generalizations to total populations are thus difficult to make with any degree of confidence. The use of small sample sizes warrants the need for replication studies. If similar results are obtained from these replication studies, generalizations to other populations are more appropriate. Sampling error and sampling bias. Sampling error is defined as the difference between data obtained from random sample and the data that would be attained if an entire population were measured. Sampling error is not under the researcher's control. It is caused by chance variations that may occur when a sample is chosen to represent a population. Sampling bias groups. Probability sampling allows the researchers to estimate only the chance that any given population element will be included in the sample. It allows inferential statistics to be used with greater confidence and gives the researcher the ability to generalize the findings of a study to the entire population. Simple random sampling is a type of probability sampling that ensures that each element of the population has an equal and independent chance of being chosen. The advantages of simple random sampling are little knowledge of the population is sufficient, it is the most unbiased probability method, and it is easy to analyze the data and compute errors. The disadvantage of simple random sampling are a complete list of population is necessary and it is time consuming. The steps in obtaining a simple random sampling are to identify the accessible population or list all the elements of the population, select a method for choosing the sample. It may be as simple as drawing slips of paper that represent each element from a hat. Stratified random sampling is a random sampling process in which sample is selected after the population has been divided into groups, subgroups, or strata according to some variable importance to the research study. A simple random sample is then taken from each of these two subgroups. Two approaches for selecting a sample using stratified random sampling are first, proportional stratified sampling, and second is disproportional stratified sampling. The advantages of stratified random sampling are it increases the probability of a sample being representative and it ensures an adequate number of cases for subgroups. The disadvantages of stratified random sampling are it requires adequate knowledge of the population and it may be costly to prepare stratified lists and statistics are more complicated. Cluster random sampling is selecting large groups or clusters to become the sampling units rather than individual people from the population. Then successive steps of selection are done. During each phase of sampling from clusters, simple, stratified, or systematic random sampling may be used. The advantages of cluster random sampling are it saves time and money, arrangements are made with a small number of sampling units, and the characteristics of clusters as well as those of the population can be estimated. The disadvantage of cluster random sampling are it causes a larger sampling error than other probability samples. It requires assignment of each member of the population uniquely to a cluster, and statistics are more complicated. Systematic random sampling is a random sampling process in which for example, every fifth person, every eighth person, or every 21st element or member of the population is selected for the sample. To perform this type of sampling, the researcher obtains a list of the population, determines the sample size, determines the sampling interval, for example, every fifth or every eighth or every 21st person, and selects a random starting point. They then select the element as they describe. The advantage of systematic random sampling are that it is easy to draw a sample, economic, and a time-saving technique. The disadvantages of systematic random sampling are samples may be biased if ordering of the population is not random, and after the first sampling element is chosen, population members no longer have an equal chance of being chosen. All non-probability sampling methods are subject to sampling bias. Random sampling procedures are subject to bias if some elements decide not to participate in the study. So in order to critique the population and samples of research studies, there are general guidelines. They are the questions that you may ask are, is the target population identified? Is the accessible population identified? Was a probability or non-probability sampling method used? Is the specific sampling method named? Is the sampling method described? Is the sampling method appropriate for the study? Are demographic characteristics of the sample presented? Is the sample size adequate? Was power analysis used to determine the sample size? Is the sample representative of the population? Are potential sampling biases identified? Is subject dropout discussed?